Okay, hello. Last day on simplifying and multiplying these rational things. This is an important day because we've got an algebra truth coming up. So you've got the three fractions, these, and you've got multiplication and division. So there are two operations, and when you have multiplication and division together, you do them in order of which you see them. So you would multiply these two first and then divide. But when you really know the order of operations, then you know how to use it appropriately. And here, dividing by this fraction, so that means this is the divisor. I can change this division to multiplication as long as I flip this divisor. So let me just do that first before I forget to. This negative x minus 7, I'm going to put down in the denominator, and 2x squared, and I also factored a little bit. So this 2x squared plus 8x, all three of these terms have a 2 in common. So that makes my factoring a little bit easier. Now I just have to find two numbers that multiply to negative 21 and add to 4. And that's positive 7 and negative 3. Don't forget, I kept my 2 there, right? My GCF. I also took out a negative here, which I don't have to do, but in this case, it benefits me if I do. And that's the algebra truth. You can always take out a negative, always. And when you do factor out a negative number, two things are going to happen. You're going to have a negative 1 on the outside of the parentheses, which is what I've got here, and both of these signs are going to change. You had negative x suddenly becomes just x, and minus 7 suddenly becomes plus 7. So you have to change all the terms. That's the algebra truth. Now this polynomial and this polynomial you could factor, and I accidentally did, but I don't really want you to factor. I want you to recognize that these two trinomials are identical. And so if you divide them, they will just equal 1. They're the same factor. We don't have to factor it to break it up to know that they're the same thing. So I could just divide them out to get 1. But I was a little bit hasty and I just divided. And then let's see, what else do I have? These two are gone because I divided those out. They equaled 1. But now I've got x plus 7 and x plus 7. They divide out to equal 1. They divide out to equal 1. And now you can see the benefit of me factoring out a negative 1 here, because I would be left with x plus 7 here, which divides out with this x plus 7. But don't forget about this negative 1 that you factored out. Do you see that you can do that again? You've got positive 1x, negative 3. Well, you've got negative 1x, positive 3. These two are complete opposites. Again, positive 1x, negative 3. Negative 1x, positive 3. They're exact opposites. To prove it, I guess you could factor out a negative 1. That's our algebra truth. You can take out a negative 1 from both of these things. There's a negative 1 outside of the parentheses. Positive 3 becomes negative 3. Negative minus x becomes plus x. And now I could just rearrange these however I want. I've got positive x, so I could just start with positive x. I've got minus 3 here. I could just end with minus 3. And what is the advantage? Well, I hope it's obvious that x minus 3 divided by x minus 3 will divide out to 1. And now what's left over? I've got, in the numerator, I've got 6 as a factor times 1 times 2 times 1. Well, that's just 12. The denominator, I've got 1 times negative 1 times negative 1 times 1, I guess. And so the denominator is really just negative 1 times negative 1. And 12 divided by negative 1 times negative 1 is just 12. So this is kind of a really kind of a silly example because it starts off with this huge expression, a fraction times another fraction divided by a fraction. We factored a bunch, we canceled out a bunch, and we're left with 12. And it is true, it does just equal the number 12, and we can prove it by looking at the graph very quickly. Here, you're just going to take my word for it. I'll show you really quick if the computer is not freezing up. It's the original one. I already changed it from division to multiplication, and I flipped this divisor. If I graph that, watch what happens. Right there. That's the line y equals 12. In other words, in this line right here, watch. Y equals 12. In other words, just 12. If you're just going to graph 12, you're really saying you're graphing y equals 12. It's just this flat line. So I hope you're convinced that this big fraction, a fraction times a fraction divided by another fraction, really just boils down to 12. But you show that algebraically. All right, one more example. A fraction times a fraction divided by a fraction. Factor, 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 factor. This factors into x plus 3, x plus 2. This, I want you to think of what this factors into, because a lot of people make a mistake. This is a difference of squares. So it's going to be 5 times x times 5 plus x. Because 5 times 5 will get you 25. Negative x times x will get you minus x squared. This denominator will factor into x plus 5 times x plus 2. And I changed division to multiplication. And I'm going to flip these. So this 3x squared minus 27 is going to go up on top. But I noticed that they both have a 3 in common. So I'm going to factor that out first. And then you could factor this. This is x minus 3 times x plus 3. But one thing at a time. And then this goes in the denominator. These both have a 6x in common. So I factor that out. I'm left with x squared minus 9. And why would I continue factoring? X squared minus 9 divided by x squared minus 9 is 1. Not 0, 1. What else do I have? X plus 2 divided by x plus 2 is 1. And is that it, guys? Well, 3 divided by 2 times 3, isn't 6 2 times 3, is 2. And 5 plus x divided by x plus 5 is 1. These two aren't the same. They really look similar. But they're not the same. This is positive 5. This is negative 5. This is minus x. This is positive x. But they are complete opposites. So you could factor out of negative 1. It doesn't matter from the top one or the bottom one. It doesn't matter. You could do it to any polynomial. That was our algebra truth over here. So if I factor out a negative 1 from here, I'm left with negative 1 on the outside. These two signs change. So negative x, positive 5. And then it factors into that. So I end up getting 5 minus x divided by 5 minus x is 1. So what do I have at the end of the day? In the numerator, I got x plus 3 times 1 times 1 times 1 times 1 times 1. So it looks like x plus 3 is just alone in the numerator. In the denominator, remember this x minus 5 became that, which became this. And what's left over? Well, negative 1 is left over. Negative 1 times 1 times 1 times 1 times 2 times x times 1. So what was in the whole bottom? Negative 1 times 2 times 6. And that is it. So you take a positive divided by a negative, the whole thing's a negative. X plus 3 over 2x. This x and this x do not cancel out because this x is a factor. It's x times 2. But this x is not a factor. It's x plus 3. So this whole nasty fraction up here is really the same thing as this. And we can show by looking at the graph. Here's that original fraction, that original, and it looks like this, like so. Here's our final answer, remember? Let me blot this and show that. They're the same. They are the same.